Okay, we've talked about domain of a graph, but we haven't really looked at a function where you just figure the domain out. Okay, so first of all, a domain of a function is the set of all permissible values of x. We've already learned that. Domain's talking about x values. Now, we're going to kind of categorize this with certain kinds of things. Okay, we've learned about a linear function. What is a linear function standard form? F of x equals what? Mx plus b. Okay, that's the standard, the slope-intercept form like that. A quadratic function, which one is that? Ax squared plus bx plus c. Okay, that's the one that's the trinomial that you're used to factoring. Okay, so what you'll have on this then is the domain of a linear or quadratic function is always going to be all real numbers. Okay, and the reason is you're going to have a line. A line goes on forever left and right. What does a quadratic function's graph look like? That's the parabola, right? So a parabola goes forever to the left, forever to the right. So basically, anytime you have a linear or quadratic function, it's all real numbers. If you write that in interval notation, then it goes like that, okay? Next one is a rational function. So a rational function is usually something like this. We say like f of x, and then you have a function in the numerator and you have a function in the denominator. Just to kind of keep it simple, it's really two polynomials in a ratio, okay? So if you remember when you're doing a domain, some of you might not have got that handout. If you have a fraction, what are you looking for? You're looking for where the denominator is what? 0. Okay, so if you're looking for a domain on a rational function, you always want to just set the denominator equal to 0. And that's what you do when you're dealing with a rational function like that, okay? So let me give you, have you write down a couple of examples of that. Okay, let's say we have f of x equals 1 over x squared minus 4. You can probably do this in your head. What makes the denominator 0 in your head? 2, what else? Negative 2, there's two things. So what you do is you set your denominator equal to 0, and then you can solve that. You could either do the square root property or you can factor it. Doesn't make any difference. This time I'm just going to go x squared equals 4. Then I'm going to square root both sides. So I get x equals plus or minus 2. And then you would write the domain like this. Okay, basically what you would say, there's two ways to do this. First thing I'm going to talk about is what we call set builder notation. And we'll get to this a little bit later in here. If I ask for set builder, you put a set brace, then you say x, and then a bar, then you just say x is not equal to plus or minus 2. It's good enough to write it that way. Set builder notation just says, okay, you're telling me what x can be. You're just saying it's all the x's. X can really be anything except plus or minus 2. That's called set builder notation. You write that as set of x such that. That's just a mathematical symbol for such that, and you'll see me do that all the time, okay? So that would be what you're doing. We're going to get into this a little bit more in depth here in a minute, but that's the idea on a rational function. Just figure out what causes a 0 denominator, and the answer is going to be everything except those things, okay? That's the way rational functions always work. Okay, now a square root. What you're going to do is set the expression under the radical greater than or equal to 0. Okay, so let me give you two examples here. If you had f of x equals the square root of x minus 3, what you have to understand as a student is what's under a radical has to be a positive number, right? Or it can be 0. What you can't have is a square root of a negative number. Okay, so what you do, the reason you do greater than or equal to 0 is because of this. The square root of 0 is cool, that's 0. Square root of a positive number is positive, that's cool. But what isn't is the square root of a negative number. So you say either 0 or bigger. So the way you find the domain on this is you just take that x minus 3, set it greater than or equal to 0, and solve that inequality. In this case, that inequality is super easy to solve. You would just add 3 to both sides, so you'd have x is greater than or equal to 3. So the way you would write this domain is you would say set of x such that x is greater than or equal to 3. That would be one way to do the domain. We'll get into the interval notation here in a few minutes like that. Okay, does that make sense? Okay, so if you have a square root function, whatever's there, set it greater than 0 and solve. That's how you figure out your domain there. Now, there's one other thing that can kind of happen with a square root. Let's write this down. say that you had g of x equals, say, 1 over the square root of x plus 2, okay? If you want to find the domain on that, well, first of all, that thing right there has to be either 0 or positive, but you got to be careful about this. Okay, notice on this one I said set the denominator greater than 0. I didn't say equal to 0. How come? Because you can't have a 0 denominator, okay? So you wouldn't want to say x plus 2 is greater than or equal to 0 because that radical's in the denominator. So what you do to figure this domain out is you do this. You say x plus 2 is greater than 0, subtract 2 from both sides, you would have x greater than or equal to negative 2. If you don't understand this, just do this real quick. What would happen if you plugged negative 2 in? You'd get square root of 0, but that 0 would be a 0 denominator, so you can't use it. That's why you used greater than and not greater than or equal to. Is that clear? Okay. So you would write the domain like this. You would say set of x such that x is greater than negative 2 like that, okay? So I'm trying to we're only going to focus on certain kinds of functions at the beginning here like that. So I'm going to do some specific examples and kind of show you what we're trying to put together here. Okay, what kind of function is this? That's linear, that's a line. It's y equals mx plus b, okay? What does a line look like? It goes like that. My question is there anything that x cannot be? Be anything. I can't think of any number that I cannot multiply by 3. You can't either, right? So the domain's everything. Anytime you have a linear function, this answer is automatic. So you don't even have to think about it. So basically, is there any value that x can't be? No. So the domain, what we would do is we would say this. If I ask for set builder, you say set brace, then you say x such that, now you have two ways you can do this. You could just say x is a real number. You can write it out that way if you want to. Okay, if you want to be really like a mathematician kind of a guy, then you go like this. I'd recommend you learn this and learn it now. Just say the set of x such that x is an element of the real number system. Because you'll see me do that all the time. It's an abbreviation. That just means it's an element of, and then that symbol is just real numbers. So anytime you see me do that, that's just shorthand notation for that. Now, interval notation, you know. How do you do interval notation if the answer is everything? Negative infinity to infinity, right? So one of the things I want you to be pretty flexible about is to be able to write that domain in both ways. So if it's a line, it's automatic. There's no calculation to do. You just know that, say, okay? Right? Okay, next one. This one is what we call a rational function. And there's going to be plenty of these problems that you can just simply do in your head. Okay, that's good. Okay, anytime you have a rational function, you try to figure out, is there anything x cannot be? It'll jump out at you. What x cannot be? What can x not be? 3, okay? All right, so yeah, x cannot be equal to 3. Okay, so what you do is if you write this in set builder, you can go like this. You just say set of x such that, and usually you write it like this. X is a real number. You can just say x is real if you want to. I'm fine with that. Then you just say x is not equal to 3. Now, I wouldn't care if you just did this. If you just said set of x such that x is not equal to 3, you can write it that way because that would just imply to me and to you that x is everything but 3. So if you want to just write it that way, that's perfectly acceptable. Okay? If you do this in interval notation, you have to do it like this. You have to say negative infinity to 3 with a bracket, then you say union 3 to infinity like that. And what that's doing is, well, why do I put a parenthesis on the 3? Because you can't be 3, right? So that's just saying everything, but you can't be 3. That's basically the standard way you're going to write the domain is like that, okay? Okay, the next one's a little harder to do in your head, but it's still a rational function. So what you do is you just look at that denominator and you set it equal to 0. Well, we've already learned how to do that quadratic equation. How do you solve that? You solve it by factoring, right? If it doesn't factor, you go to the quadratic formula. So this one, you would just, when you factor this, you would have x and x to get the x squared. You would have 8 and 2 to get the 16. And you'd have a plus 8 and a minus 2 like that. Okay? So the solution of that equation is x equals -8 and x is equal to 2. Okay, that's going to be the two places that x can't be. So the two things that x couldn't be would be -8 and 2 like that. Now you can't do that in your head, so you just set the denominator equal to 0 and solve the equation. Everybody okay there? Okay. So set builder, you would just go like this. You would just say set of x such that, and just say x is not equal to -8, comma, x is not equal to 2. Now, if you wrote x is not equal to -8, comma 2, I'm okay with that. Okay, you just got to tell me, if you write that way, you're just saying it's everything except those two numbers, okay, like that. Okay, interval notation, you got to use 3 intervals if you do this. You would have to say -infinity to -8, union -8 to 2, and then union 2 to infinity like that. And again, what that's doing is it's just saying everything on the number line, but no 8 and no 2. And you do that from left to right. Everybody with me there? Okay. So you want to be kind of interchangeable in how you do that. Usually on a test, I say, I'll tell you, I want set builder, or I want interval, or maybe I want both. Okay. Okay. This one is the square root function. So the key thing on this one is this. Just think this, okay? First of all, what kind of number has to be under the radical? 0 or bigger. Don't forget the 0. 0 or bigger. Because the square root of 0 is okay. So in order to figure this out, you would just need to take the 8 minus x and set it greater than or equal to 0. So you got to solve that inequality set, right? Now be careful with this inequality. What I'm going to do is I'm going to move the 8 there. So I have -x is greater than or equal to -8. Watch this carefully. A lot of times students slip up on this. You would divide both sides by -1. And we talked about this a little bit. That's x. That's 8. What do you got to do? Switch the sign. Remember, anytime you divide or multiply by a negative, you're messing up the order of things on the number line. So you got to do this. And if you don't catch that, that's going to mess up your domain. Okay, so basically, x has to be less than 8. Now, let me show you this, how easy it is to recognize this. So what happens if x is 8? What do you have? You have square root of 0, right? 8 minus 8, 0, that's cool. Give me a number less than 8. Let's say 7. What's 8 minus 7? 1. Square root of 1? Cool. Give me a number like 9 that doesn't fit in that interval. What happens if you do 8 minus 9? A negative number, it doesn't work. So when you get that domain, you can kind of plug it back in and see if it's jiving the way it's supposed to. So basically, any numbers x cannot be would just be all the numbers less than or equal to 8. So you would say in set builder, you would say set of x such that x is less than or equal to 8, and that's all you got to do. Interval notation, you say -infinity, comma, 8 with a bracket like that. Okay, so that's it. Okay, everybody good there? Okay, all right. Okay, let's see, the next one. Oh, I got to be careful about this one, okay? Well, basically on this one, there's one thing I want to talk about with this problem. First of all, you want to look at what causes the denominator to be 0. In your head, what causes the denominator to be 0? 2 and -2. There's two things. You got to be careful. Now, what I want to show you is this, and you want to make a note to yourself on this. I made this problem up on purpose. If you factored the denominator, wouldn't you just get x plus 2, x minus 2? Okay, but now that doesn't, and that you don't worry about that cancellation. Okay, don't cancel it and say, oh, it's 1, so therefore the domain's everything. That is not right. What you're always doing on a domain, even if stuff cancels, you're always looking at where that original function is undefined. So you cannot be -2 and 2, even though that stuff cancels out. Okay, all right. So what you would say on this is you cannot be -2 and 2. The domain and set builder, you would just say set of x, and then you can say x is not equal to plus or minus 2. You can write that abbreviated form like that. Okay. Interval notation, you'd have to do 3 intervals. So you'd have to say -infinity, -2, union, negative 2, 2, union 2, infinity like that. But the note you want to make on yourself is the cancellation doesn't mean anything on that. Okay, you're looking at the original function regardless of anything that cancels. Okay, that's real important. Because actually, if you graphed that on a calculator, it would just be a horizontal line, but it would have two little bubbles in it where it's undefined. That's how that would work out. Okay. Okay, well, let's do this, and then I wanted to kind of just introduce you to a little bit of algebra functions tonight, too. You've got to be really careful with this one and how you do this. So, first of all, what jumps out at you is what x can be. 6, okay? That's one thing, okay? So x cannot be equal to 6, so you can't be 6. Okay, so what I'm going to do on this one is I'm going to put this together, and, you know, sometimes if you simplify it, you might find something else. So I'm just going to write this as x over 1 minus 3 over x minus 6 like this. I ain't going to make any difference on this. So what I'm going to do here is I'm going to, I got a common denominator of x minus 6. So I'm going to do this. It ain't going to make any difference on this, but there are times when putting it together, you might identify something else in the problem. So what you'd have is x squared minus 6x over x minus 6 minus 3 over x minus 6. So you'd end up with f of x is equal to x squared minus 6x minus 3 over x minus 6. But it doesn't make any difference. I mean, after I do that, hey, it's still x can't be 6. The numerator can be anything, right? Okay, there's no problem with that numerator. There's no square roots or anything. So what you'd write on this is you'd just say the domain would be set of x such that x is not equal to 6 like that. And then interval notation, you would say negative infinity to 6, union 6 to infinity like that. Okay, and that would be it. Okay? All right, let's go ahead and stop here. That's a great stopping point because now we're kind of into to a different place here. Okay, all right, everybody okay? Okay, everybody keeping up good? And, okay, having a blast with all this homework I'm giving you?
I come in class ready for more.
Sorry, I mean, pre-calc is, we do load people up in pre-calc because it's condensed. And so it's just the reality of what it is. You guys are trying to get ready for calculus next semester, so you're going to do a lot of homework. It's just the reality of what you're doing. Yep.
Okay, so you would be